हेलो,
यस सर।
चलो आगे लोगों को आना था, बाकी लोग नहीं आएंगे क्योंकि वो कैसा है, मैंने सबको बोला था इन्वेस्ट वालों को अगर आना है तो आ सकते हो, नहीं आना है तो कोई प्रॉब्लम नहीं है, इसलिए वो नहीं आएंगे शायद। ओके, तनिष्का क्या कर रहे थे कल हम लोग? हेलो आदर्श, हेलो, क्या कर रहे थे? इलेक्ट्रिसिटी?
सर मैं कल लेट सोऊंगा बहुत।
अच्छा, कौन था कल क्लास में स्टार्टिंग से? कोई भी नहीं था इनमें से। तनिष्का यू आर देयर ना?
यस सर।
कहाँ तक किया था कल हम लोगों ने?
क्या सिखा रहे थे कल आप?
कल शायद करंट इलेक्ट्रिसिटी कर रहे थे हम लोग, राइट आदर्श?
यस सर।
हेलो आदर्श, कहाँ तक हुआ था कल? फैक्टर्स अफेक्टिंग रेजिस्टेंस। ओके, तो
Yes,
हाँ, फैक्टर्स अफेक्टिंग रेजिस्टेंस तक हमारा कल हो गया था, हम डिवीजन कर रहे थे इलेक्ट्रिसिटी का। ओके, नाउ सी क्या होता है। सो हमने कल क्या देखा था कि if you change the potential difference across the conductor, then okay, the current also changes. Okay, suppose ये आपका रेजिस्टेंस है, ओके, देन यहाँ पर आपने वोल्ट मीटर को कनेक्ट किया, ओके, प्लस माइनस, देन यहाँ पर आपने आपका एमीटर कनेक्ट किया, प्लस माइनस, देन इधर एक की है, ओके, देन पहले बैटरी लगाई, बैटरी लगाने के बाद में यहाँ पर इस वायर को ओपन छोड़ दिया, इधर एक की लगाई और की लगाने के बाद में वायर उल्टा रखा, ये पॉजिटिव टर्मिनल, ये नेगेटिव टर्मिनल, ओके, देन सो क्या होता है इसके अंदर कि सी हमारे पास में भी चार ऑप्शन है, ओके, हम चाहे तो इस वायर को, ओके, देन वो चार पॉइंट में से पेपर भी कनेक्ट कर सकते हैं। अगर यहाँ कनेक्ट किया तो ओनली वन सेल विल बी कनेक्टेड, यहाँ कनेक्ट किया तो टू सेल्स विल बी कनेक्टेड, यहाँ किया तो थ्री सेल्स विल बी कनेक्टेड और यहाँ किया तो फोर सेल्स विल बी कनेक्टेड। ओके, अब क्या होगा, जैसे जैसे नंबर ऑफ सेल्स चेंज होंगे, जैसे जैसे नंबर ऑफ सेल्स चेंज होंगे वैसे वैसे क्या होगा कि करंट भी चेंज होता जाएगा, करंट भी चेंज होता जाएगा। तो हम यहाँ पे क्या करते हैं, वी राइट डाउन द पोटेंशियल ओवर हियर करंट एंड देन हियर वी डिवाइड द V by I, sorry V by I and write down it over here. Okay, now what happens here, see अगर सपोज हमने यहाँ पर जो ये मैं इमेजिनरी वैल्यूज लिख रहा हूँ, करंट वोल्टेज लिया हमने 2 वोल्ट, ओके, करंट आ गया हमारा 0.1, अगर हमने वोल्टेज लिया 4, करंट आ गया 0.2 और वोल्टेज लिया 6, करंट आ गया 0.3, देन तो इस तरीके से जैसे जैसे वोल्टेज बढ़ता है वैसे वैसे करंट भी बढ़ता जाता है। ये मतलब ये डायरेक्ट वेरिएशन हो सकता है, ठीक है। अब है या नहीं है ये कंफर्म करने के लिए हम क्या करेंगे, इसको इससे डिवाइड करो, so 2 divided by 0.1 will be equal to how much, 20, 4 divided by 0.2 will also be equal to 20, 6 divided by 0.3 will also be equal to 20। मतलब क्या हो रहा है कि यहाँ पर potential difference and current are directly proportional to each other, they are directly proportional to each other, okay, and because of this what will happen, as they are directly proportional to each other, then okay, see V is proportional to I, okay, and this V will be equal to some constant R required, okay, जब कभी भी proportionality रहेगी तो वहां पर एक constant of proportionality भी रहेगा, okay, वो ओके, और सो इसे क्या हो जाएगा v इक्वल टू r into I। मगर ये स्टेटमेंट जो है तो इट होल्ड्स ट्रू ओनली इन सम स्पेसिफिक कंडीशंस। ओके, इट होल्ड्स ट्रू ओनली इन सम स्पेसिफिक कंडीशंस। क्या होता है वो कंडीशन? द कंडीशन इज लाइक दैट कि यहाँ पर क्या होता है कि चार चीजें होती हैं जो बदलनी नहीं चाहिए। ओके, एक तो फोर थिंग्स आई मेंट फॉर स्टार्ट। एक्सक्यूज सॉरी बेटा। फिर व्हाट हैपेंस, सी ये जो इक्वेशन है v इज इक्वल टू r है, दिस विल बी ट्रू ओनली इफ, दिस विल बी ट्रू ओनली इफ सपोज द लेंथ, दिस विल बी ट्रू ओनली इफ द लेंथ ऑफ वायर, ओके, देन सेकंड एरिया ऑफ क्रॉस सेक्शन ऑफ वायर, ओके, देन टेम्परेचर ऑफ वायर, ओके, एंड नेचर ऑफ मटेरियल ऑफ वायर। Temperature of wire and nature of material of wire remain same, material of wire remain same। अगर ये चारों चीजें सेम रही तभी ये इक्वेशन ट्रू होती है। ओके, अब हमने अगर इन दोनों को कंबाइन किया तो वी गेट द ओम्स लॉ। ओके, व्हाट डज द ओम्स लॉ से? ओम्स लॉ सेज दैट if the physical conditions and temperature, okay, the physical conditions and temperature, physical conditions such as length, area of cross section, nature of material and temperature remain constant, then V is directly proportional to I। Okay, I will repeat the statement. According to Ohm's law, if the physical conditions and temperature across the conductor remain the same, then the potential difference across the ends of the conductor is directly proportional to the current flowing through it। The potential difference across the ends of the conductor is directly proportional to the current flowing through it। Okay, then this is Ohm's law। Okay, now what happens over here? If you plot the graph of V versus I, if you plot the graph of V versus I, okay, then you will get a straight line, you will get a straight line। Okay, suppose this is your potential difference and here is your current, okay, V I, okay, 0 0, okay, 1 2 3 4, this see 1 2 3 4, suppose voltage 1 volt, 2 volt, 3 volt, 4 volt, current 0.1 0.2 0.3 0.4, okay, then you will find that the graph comes out to be a straight line, the graph comes out to be a straight line। Okay, then so the VI graph of a conductor will be a straight line passing through the origin। Okay, if you take 2 points on this conductor, any 2 points, suppose I have taken this point as A and this point as B, then write down the coordinates of point A। What are the coordinates of point A? Is x1 y1, which will be equal to how much? 0.2, then 2, then B x2 y2, okay, it will be 0.4 and 4, 0.4 and 4। Okay, so what happens? Calculate the slope over here। Okay, when you calculate the slope, you will find out what is the formula for slope? y2 minus y1 upon x2 minus x1। So in this situation, what will happen? It will come 4 minus 2 upon 0.4 minus 0.2, so it will come 2 upon 0.2 is equals to 10। Okay, and this tells nothing but the resistance, this tells nothing but the resistance। Okay, remember the slope of VI graph, the slope of VI graph will give you the resistance। Okay, more slope more resistance, less slope less resistance। Okay, I'll draw here 2 graphs। Okay, then see that if suppose I plot the 2 graphs over here, look at those 2 graphs। Okay, then here one graph is, means both the graphs are plotted on the same paper। This VI, this is origin 0 0, one here, one here। Then see, this is resistance R1, this is resistance R2। Look at these two and tell me which has greater resistance, R1 or R2? Which is greater, R1 or R2? Okay,
R1,
no, तनिष्का R2, बिकॉज क्या होता है R1 R2 का इंक्लिनेशन ज्यादा है, जिसका इंक्लिनेशन ज्यादा उसका स्लोप ज्यादा, जिसका स्लोप ज्यादा उसका रेजिस्टेंस ज्यादा। ओके, ये किसके लिए है? ये वी आई ग्राफ के लिए है। लेकिन अगर हमने सेम ग्राफ को आई वी ग्राफ कर दिया, मतलब आई इधर ले लिया और वी इधर ले लिया, ओके, then here it is I and here it is V, then 0 0, this is R1, this is R2. So now you can say that R1 is greater than R2. Now R1 is greater than R2, because here what happens, see, the slope of this one is more. Why? Because it is IV graph, not VI graph. So in that case what will happen, R1 will be greater resistance and here R2 will be the greater resistance. Okay, so here we are talking of the resistance, but actually what is resistance? Okay, then see here, if you check practically, then what is resistance? So you will find that, see here, this what happens when suppose an electron wants to move through the conductor. Suppose this is the magnified view of the conductor. Here there are the positively charged nuclei present in the conductor, okay, and one negatively charged electron want to pass through this. Okay, so when this electron will pass through it, okay, what will happen? Then see, it will collide with the nucleus. Then from here it will go here. Then from here again here. So in this way what happens? See, when the electron tries to move through a conductor, it continuously collide with the nuclei. It continuously collide with the nuclei, and because of these collisions, it cannot move freely. That is why we say that it is experiencing the resistance. Okay, so in short, what happens? Whatever the obstacles will come, okay, that is that those obstacles, then they are supposed to, or they are said to create the resistance. So in short, we say that resistance is nothing but resistance. Okay, then it is the property of the conductor. The property of the conductor. Property of the conductor to oppose the flow of charges. Conductor to oppose the flow of charges. Oppose the flow of charges through it. The property of the conductor to oppose the flow of charges through it is called as resistance. As the resistance. Okay, it is called as the resistance. Okay, this is the definition of resistance. Okay, and you should know, okay, what happens? This obstacle, this resistance is because of the collisions. This resistance is because of the collisions. Okay, and here what happens when you see that V is proportional to I, we write it that V is equal to some constant R into I, and this R over here which is equal to V upon I. Okay, this R is called as the resistance. So, what is the resistance? Mathematically, the resistance is the ratio of the potential difference to the current. Resistance is the ratio of the potential difference to the current, and its SI unit is ohm. The SI unit is ohm. So, SI unit is ohm. Okay, now what is 1 ohm? Okay, what is 1 ohm? Okay, how will you define 1 ohm? So, let us see over here what is 1 ohm. Okay, so see, what happens if you get R is equals to 1 volt R is equals to V upon I. V upon I. Then, so 1 ohm will be equal to 1 volt upon 1 ampere. 1 ohm will be equal to 1 volt upon 1 ampere. Okay, then now, how will you define 1 ohm? Okay, so read this equation in English. Read this equation in English. Then, when a potential difference, okay, of how much volt? 1 volt. When a potential difference of 1 volt is applied, कहाँ पर अप्लाई करते हैं उसको? Across the ends of a conductor. Is applied across the ends of the conductor. Across the ends of the conductor. Across the ends of the conductor. Okay, and it sends a current of 1 ampere through it. 1 ampere through it. Okay, through it. Then the resistance is said to be of 1 ampere. Then the resistance is said to be of 1 ampere. Resistance is said to be of it. Okay, it's simple. Okay, why simple? Because you know that potential is applied across the edge of the conductor and current passes through the conductor. Okay, so mention that two things. Okay, when the potential difference of 1 volt is applied across the edge of a conductor and it sends a current of 1 ampere through it, then the resistance is said to be of 1 ohm. Then the resistance is said to be of 1 ohm. Okay, then this is the what we say definition of 1 ohm. Okay, now see, as we discussed that the resistance is mainly because of the collisions between the electron and the nuclei present in the atom. So what will happen over here? See, suppose this is your conductor. Okay, and in your conductor there are many nuclei. Okay, many nuclei. Okay, then so what happens? See, as the electron will try to pass through this conductor, okay, it will collide with the nuclei. Okay, and because of that it will experience a resistance. Okay, and what happens over here? Suppose in 1 meter wire there are 1000 collisions. There are 1000 collisions. Then in 2 meters there will be 2000 collisions average. Okay, so from this we should understand one thing, that the resistance is directly proportional to the length. As the resistance will increase, the length will increase, the resistance will also increase. So we could get a first factor over here which will affect the resistance of a conductor, and it is its length. Okay, now what happens over here? If suppose we increase the area, see, if suppose the wire is thin, okay, if the wire is thin, then what will happen? Then at a time only 1 or 2 electron can pass, just telling you, because at a time millions of electron pass from here. So here we can assume that only 1 electron is able to pass. Okay, take one more that will be able to pass from this side, or one more from this side. Now what will happen if you increase the area? Okay, you double the area. Okay, when you double the area, then you will have many advantages now. Okay, what are the advantages? Then 1 electron will pass from here, 1 electron will pass from here. If any electron gets stuck over here, it can go this way also, because what happens? The optional paths will be open. So in short, what happens? As the area increases, the movement of the electron becomes easier. Means the resistance decreases. Area increases, resistance decreases. So what we conclude? We conclude that the resistance and area are inversely proportional to each other. So resistance is inversely proportional to area. Area will increase and the resistance will decrease. Okay. Then third thing. Okay. Now the third thing is the nature of the material of the conductor. So here what happens? See, if suppose you are using a pure metal. So what happens in case of the pure metal? Then all the atoms will be identical. Okay, if the atoms are identical and of same size, then what will happen? The electron will be easily passing through them. Okay, yes, of course it will face the resistance, it will collide with the nuclei, and it will have the resistance. But what happens if suppose the alloy is formed? Then what will happen? In alloy, some of the atoms are big in size and some of the atoms are small in size. So what will happen? Those small atoms may block the gap available in between also, and because of this, what will happen? Then the movement of the electron will become very, very difficult. So what happens? In short, the resistance of the conductor depends upon nature of material, whether it is pure metal or an alloy or an insulator. Okay, even if it is metal, then in the metal the size of the atom matters, then number of free electrons matter. In this way, there will be many factors which all are included in the nature of material. So what will happen over here? The resistance of the conductor will depend upon nature of the material of the conductor. Okay, it will depend upon nature of material of conductor. Okay, but nature cannot be fixed or decreased. So we can say that nature depends upon resistance depends upon nature. Okay, how it depends? We have to find out the nature of the material, then only we can say. Okay, the fourth factor is temperature. Okay, you all know that what happens when the temperature rises? What happens to the atom when the temperature rises? If suppose in any material temperature is rising, then all the atoms start orbiting. Okay, actually they won't. But we assume that the atoms were stationary and the electron was going in polarity with them. But when the temperature will rise, the atom will start vibrating, and the atoms will start vibrating. What will happen now? There are possibilities that not only the electron will collide with the nucleus, but the nucleus may also collide with the atom. And that's what happens with the rise temperature. With the rise in temperature, what will happen? This kinetic energy of nuclei. Kinetic energy of nuclei increases. Kinetic energy of nuclei increases. Thus, collisions increases. Thus, collisions between nucleus and electron. Between nucleus and electron. It's atom and electron also. Nucleus and electron. Okay, and hence increases. Increases, and hence the resistance also increases. Resistance also increases. Resistance also increases. So now, किस तरह से स्टार्ट करते रहेंगे? First is directly proportional to length. Second, inversely. Third, depends upon nature. And fourth one, R is directly proportional to the temperature. Okay, as the temperature will rise, the resistance will also rise. These are the four factors. Okay, then after studying these four factors, then we move forward towards the new quantity over here. Okay, see now what happens, as we have discussed just now that resistance is proportional to the length and inversely proportional to the area. So keeping these two things in mind, okay, then see if you combine these two equations where the resistance is directly proportional to length, okay, and resistance is inversely proportional to the area. Okay, so when you combine these two, what will happen? Then you will get that resistance is proportional to L upon A. Okay, and therefore as there is a proportionality, there will be a constant of proportionality which says that R is equals to rho L upon A. R is equals to rho L upon A, where rho is a constant of proportionality. Okay, it is rho, RHO, constant of proportionality. Constant of proportionality. And this constant of proportionality, okay, is called as the resistivity. It is called as the resistivity. Here it is called as the resistivity. Resistivity. Okay, or specific resistance. Specific resistance. It is called as the resistivity or specific resistance. Okay, why specific? I'll tell you now. Okay, actually what happens? A normal conductor can have any length and any area cross section. A normal conductor can have any length and any area cross section. But here in this case, okay, what we do, we take L is equal to 1, okay, 1 meter, okay, and A is equal to 1 meter square. If you substitute these two values in this equation, you will get R is equals to rho. R is equal to rho. So resistivity is equal to resistance. But which resistance? A specific resistance of a conductor, of in fact of the material of the conductor of unit length and unit area of cross section. Okay, when the length and area will be 1 that time the resistance of the conductor will become the resistivity. The resistance of the conductor will become resistivity. See, I always give the same example. Suppose if you have a circle, okay, then what is this line called as, which intersect the circle in 2 points? It is called as the chord. It is called as the chord. But okay, if the same chord passes through the center of the circle, okay, then we call it as the diameter. Why? Because it is specific. Because it is specific. In the same way, if suppose there is a normal piece of material, okay, with any length and any area cross section, then it will have the resistance. But when the same wire or the same material will have the unit length and unit area cross section, then its resistance will be called as the resistivity. Okay, that is why we define the resistivity as the resistance of a conductor of unit length and unit area of cross section. Okay, then the resistivity is defined as the resistance of a conductor resistance of a conductor of unit length and unit area of cross section. Unit length and unit area of cross section. Unit area of cross section. Unit length and unit area of cross section. Okay. This is the definition of the resistivity. Resistivity is the resistance of the material of a conductor of unit length and unit area of cross section. Okay. And for any conductor when the length and area of cross section are equal, then whatever the resistance it will have, that will become the resistivity. Okay. Now see, in short, what happens in geometry, we have one figure which is the unit length and unit area. Okay. If you take a cube of side 1 meter, if you take the side of cube of side 1 meter, 1 meter, 1 meter, 1 meter, then the area of cross section will be equal to how much? 1 meter square, and the length will be equal to how much? 1 meter. So whatever the resistance this cube will have, whatever the resistance this cube will have, that will be the resistivity of the material of it. That will be the resistivity of material of it. Okay, this is the definition for the resistivity. Now, SI unit of resistivity. Okay, how to calculate the SI unit of resistivity? Okay, then see, the SI unit of the resistivity can be calculated this way. See, write down the formula for resistance. R is equals to rho L upon A. Now, keeping rho to one side, shift everything to other side, you will get rho is equals to R A upon L. Now substitute the SI unit of resistance. It is ohm. SI unit of area meter square, and SI unit of length meter. So this will get cancelled, and you get rho is equals to ohm meter. Rho is equals to ohm meter. This is the resistivity. SI unit of the resistivity. This is the SI unit of resistivity. Okay, then this may be asked for 2 marks. Okay, derive the SI unit of resistivity. So you have to write the formula, then write down all the resistance, all the values, take in all the SI unit of the quantities, and then finally you will get the value of SI unit of rho. Okay, which is equal to ohm meter. Okay, next. After this comes factors affecting resistivity. Okay, what are the factors which will affect the resistivity? So let us see what are the factors which will affect the resistivity. So here what happens, see, if you look at the formula of the resistivity. Okay, then what is the resistivity? Resistivity R is equals to, sorry, rho is equals to R A upon L. Okay, now here what happens, see, this L is already 1 meter, so it can't change. It can't change. Then A is equal to 1 meter square. It also can't change. Okay, so now depends only what? See, resistivity will depend upon resistance, and this resistance depend upon what? It depends upon nature of material. Nature of material and temperature. Nature of material and temperature. So resistivity of a substance depends upon then nature of its material and the temperature. Only 2 factors will be there which will affect the resistivity. Okay, rest of the factors will not affect the resistivity. Okay, rest of the factors will not affect the resistivity. Okay, then so here what happens, see, if you want to write the difference between the resistance and resistivity, you can write 3 differences. Okay, first is definition. What is the resistance? The resistance is the ability of a conductor to oppose the current to it. Okay, ability of the conductor, ability of the conductor to oppose current through it, to oppose current through it. Okay, this is the definition of resistance. Okay, what is resistivity? Then resistivity is the resistance of a conductor, resistance of a conductor of unit length and unit area of cross section. Unit length and unit area of cross section. Unit area of cross section. Okay, then second difference is that resistance SI unit is ohm and resistivity SI unit is ohm meter. Okay, and then next is resistivity. Resistance depends upon length, area of cross section, nature of material and temperature. Okay, here resistivity depends only on nature of material and temperature. So these are the three differences which you can write between the resistance and resistivity. Okay, then next program resistance and resistivity difference. Okay, after this comes this resistance in series and resistance in parallel. Okay, see now in this way we are first finishing all the basic things, and then from next class we will start the things which are little complicated. Okay, tomorrow Wednesday, you want the class tomorrow, then the next class will be on Thursday. Okay, then now see resistance in series and resistance in parallel. Okay, what do you understand by resistors in series and resistors in parallel, and what is the equivalent resistance of the resistors connected in series and in parallel? Okay, see here. See. Then see resistors in series. Okay, resistors in series. What do you mean by resistors in series? Okay, see when resistors are connected end to end, it is the definition for resistors in series. When resistors are connected end to end, are connected end to end, end to end. Okay, they are end to end. They are said to be connected. They are said to be connected in series. Connected in series. Okay, this is the definition for the series resistance. Okay, when they are connected end to end, they are said to be connected in series. Okay, now see here what happens. Okay, when you connect many resistors end to end, they are said to be connected in series. So here now I draw the diagram for three resistors connected in series. Okay, see if suppose there are three resistors, okay, of resistances R1, okay, R2 and R3. Okay, here there are three resistors with the resistances R1, R2 and R3. Okay, end to end, so they are said to be connected in series. Okay, one voltmeter is ammeter is connected over here in series to measure the current through all of them. Then one battery is connected over here. Then after battery, one key is connected and the circuit is completed. Okay, now suppose a current I start to flow through the circuit. When this current I will pass through the resistance, it will produce some potential difference over here, or some potential will be dropped over here. Suppose the potential dropped over here is V1. Okay, then the potential dropped over here is V2. Okay, then and the potential dropped over here is V3. Okay, then key is closed. Okay, positive, negative. Okay, so in this way what will happen, see when you connect the three resistors in series, okay, then three different potential will be dropped across them. Okay, and now connect one more voltmeter over here which will measure the potential difference across all three of them together. Okay, so now here what happens, see if you connect this resistance of 3 voltmeter over here, as we discussed in the last class, voltmeter is very high resistance. Because of the high resistance, current cannot go in this direction, current cannot go in this direction. So the whole of the current I will go in the resistance R1, then it will go to resistance R2, then it will go to resistance R3 and come out. Okay, now what will happen, see here V1 is the amount of work done to move the charge from this point to this point. V2 is the amount of work done to move the charge from here to here, and V3 is the work done to move it till this point. Okay, and V is the total work done to go from this end to this end. So from this we conclude, from the circuit we get the idea that V is equal to V1 plus V2 plus V3. Okay, V is equal to V1 plus V2 plus V3, and this we give this as the equation 1. We give it as the equation 1. Okay, now see, according to Ohm's law, what happens? This V1 must be equal to I into R1, because potential difference is equal to current multiplied by resistance. So you will get V1 is equals to I into R1. Okay, and you will get V2 is equals to I into R2. and similarly V3 is equals to I into R3. So these are the three values. V1 is equals to I into R1, V2 is equals to I into R2, V3 is equal to I into R3. Okay, from where we got it? We got it from Ohm's law. Okay, now what happens? See, suppose we replace R1, R2, R3. Suppose we replace R1, R2 and R3 by a single resistance RP. Okay, and after replacing this R1, R2, R3 by RS, not RP, RS. Okay, then we find that there is no change. मासिर क्या कर रहे हो बेटा? There is no change in current and potential difference. No change. Okay, whatever the value of the potential difference V was there, that is same. Whatever the value of the current was there, that is also same. So in this situation we can say that V is equals to I into RS. V is equal to I into RS. Give it equation 2. Now substitute this V1, V2, V3 and V in equation 1. So you will get what over here? You will get I into RS. Okay, I into RS is equals to I into R1 plus I into R2 plus I into R3. Okay, take I common. Okay, so you will get I into RS is equals to I into R1 plus R2 plus R3. Okay, this I get cancelled and you will get RS is equals to R1 plus R2 plus R3. RS is equals to R1 plus R2 plus R3. Okay, so in this way we get the formula for the equivalent resistance. Okay, and we conclude that when many resistors are connected in series, then the equivalent resistance is equal to the sum of the individual resistances. Okay, this is the formula for the equivalent resistance of the resistors connected in series. Okay, then next. Okay, after this comes resistors in parallel. So how to get the formula for the resistors, equivalent resistors when the resistors are connected in parallel. Okay, now first of all, what is mean by resistors connected in parallel? Okay, what do you understand by the statement that there are few resistors which are connected in parallel? Okay, so let us see that statement first. Okay, resistors in parallel. Now see here what happens when you connect many resistors between 2 points. They are said to be connected in parallel. Okay, see, when two or more resistors are connected in between 2 points. Resistors are connected between 2 points. Okay, they are said to be connected in parallel. They are said to be connected in parallel. Okay, then this is the definition of the parallel resistors. Okay, so here what we'll do, we'll take 2 points P and Q, and in between those 2 points P and Q, we'll connect 3 resistors. So suppose here there are 3 resistors, then with resistances R1, R2 and R3, which are connected between 2 points P and Q. Okay, then so we say that they are connected in parallel. Okay, this is the resistance with the resistor with resistance R1, this is with resistance R2, this is with resistance R3. One ammeter is connected over here to measure the current through all of them. Then one battery, one key, and the circuit is completed. Okay, and in order to measure the total potential difference dropped across 3 of them, we connect one voltmeter over here. See, it's plus minus. So plus minus. Okay, now close the key. When you close the key, a current I will start to flow through the conductor. Okay, this current I which is flowing through the conductor, okay, it reaches to this point P, and after reaching to this point P, what happens? This current I, it get divided into three parts. Okay, a part I1 will pass through R1, a part I2 will pass through R2, and a part I3 will pass through the R3. Okay, now what happens? You know that the electrons are conserved. They can neither be created nor be destroyed. So whatever the electrons will enter from this point, the same number of the electrons will come out from this point. Okay, and that's what happens. A current I will come out. So we conclude that, see, here I was getting divided into three components, I1, I2, I3, and here it is recombining. That's why this I must be equal to I1 plus I2 plus I3. Okay, I is equals to I1 plus I2 plus I3. Give it equation 1. Give it equation 1. Okay, that is I is equals to I1 plus I2 plus I3. Okay, then next. Okay, now what happens over here? See, we know that if the potential difference between these 2 points is V, so this V is going to remain same for R1, R2 and R3. Same for R1, R2 and R3. So it will happen over here. From this we get that this I1 must be equal to V upon R1. Okay. Similarly, this I2 must be equal to V upon R2. Okay. And I3 is equals to V upon R3. Okay. This comes from the Ohm's law. Okay. Ohm's law. Okay. Then. Okay, from Ohm's law we get I1 is equal to V upon R1, I2 is equal to V upon R2, I3 is equal to V upon R3. Give it equation 3. Now once again, if you replace this R1, R2, R3 by a single resistance RP and V and R remain the same. Okay, you replace R1, R2 and R3. All these three are replaced by a single resistance RP. Okay, and this V and I are unaffected. They are unaffected. So what will happen over here in this condition? This you will get this this I will be equal to V upon RP. I will be equal to how much? V upon RP. Give it equation 3. Okay. Now look at equation 1, 2 and 3. Okay. From equation 2 and equation 3. From equation 2 and equation 3, substitute the value of I1, I2, I3 and I in equation 1. So what you will get? You will get V upon RP. V upon RP is equals to V upon R1 plus V upon R2 plus V upon R3. Okay, take V common and cancel it. So you will get 1 upon RP is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, then 1 upon RP is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so we conclude that when the resistors are connected in parallel, then the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of individual resistances. Okay, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistances. Okay, this is the formula for the equivalent resistors. Resistance of the equivalent resistors connected in parallel. Okay, then and here we found that when the resistors are connected in series, the resistance increases, but when they are connected in parallel, the resistance decreases. When they are connected in series, the resistance increases, but when they are connected in parallel, the resistance decreases. Okay, and one more thing over here. See, one very important thing. See, when the resistors are connected in series and parallel, and if suppose somebody asks you, okay, a difference between the resistors in series and resistors in parallel, then you can write it like this. Okay, in series, okay, and in parallel. So what happens in series? Series, the resistance increases. Net resistance increases. Okay, here it decreases. Okay, here current is same. Here current is same. Okay, here potential difference is same. Potential difference is same. Okay, in this way you will get the two differences between the series and parallel combination of the resistors. Okay, so we will stop here today and we'll continue day after tomorrow. Okay, tomorrow we don't have the class. Okay, thank you very much for joining.